So using our calculator on that determinant, what do? We put it in just like a matrix. So you treat it with, because it's going to be a matrix algebra. We're going to actually do problems using matrices. So first thing I do is I go into matrix like I always do, and I want to edit. Now this time I'm not putting in a 3 by 4, I'm putting in a what? 3 by 3. So 3, enter, 3, whoops. 3, and that takes me down to a 3 by 3. And then just type it in. 3, negative 9, 4, 1, 4, 0, 8, negative 3, 1. And so then check it out to make sure you've typed it in correctly. So it's there. Now remember, the calculator has deep memory. So that means that some of the last stuff that you've done is still in memory. So once you do a determinate command, unless you do a bunch of stuff, it's still going to remain in memory. And you can go back and pick it up. You don't have to go inside to get the command. Now, some of the more sophisticated calculators, and I think it's like the TI-89 is one of them, they actually have a place that you could put your favorite commands. You know, it's kind of like this is stuff I use all the time, so I just kind of put that there. But because this guy does so much other stuff, they don't. So now I'm going to come back out. I have to quit because that's the way the matrix editor is. Now I need to go back into matrix, math. Notice what's at the top of the list. DET, remember that was a determinant. That was another thing for determinant. And it says, what do you want to take the determinant of? Where's my determinant? In A, in matrix A, right? So matrix, oops, sorry. Let's go, I need to do that again. So matrix, math, edit, no math, determinant. And then you guys are there faster than me, second matrix. And then I want to pull A off. Don't have to have the end parent if you don't want to. And then at which point, if you just press enter, that'll give you the value of that determinant. And that'll be helpful for large systems, and it's equal to negative 119. So even if you have to do one by hand, you can do it, put it in your calculator, and check your answer if you want to. Now, what's going to be coming up, if I want, as long as I put stuff in A, I don't ever have to type determinant of A again. Or I could still pull it back and then put in a different matrix. So here we go. This is a way to solve a system of equations, and this is what I used when I took physics, and it was Cramer's rule. This is how I got myself into so much trouble with having to do so many determinants. And if your answers are really nasty, that's when this stuff comes to be really nice. So if my answer was 19/4, you know, if you tried to do that using matrices by row reduction, you figure your numbers inside that matrix are going to be really nasty. You try to do that by hand. So Cramer's rule says this. If you have a system, and we're going to start off with 2 by 2s because they're easy, that you can solve for x by, and it's called x is equal to d sub x over d, y is equal to d sub y over d. Now what is d? D that I've always called the determinant of coefficients. It's the coefficients of x and y. Now what d sub x is, it takes the column representing x and replaces it by the constant column. So it takes A1, A2 out, that's the coefficients of x, and replaces it by C1, C2, which is the constants of the system. And by the way, this works for any size. We can go to 5 by 5s. The rule would still be the same. It's just you'd have more of them. D sub y, it's the same thing. You're going to take the column representing y and replace by the constant column. And what that says is that x would be d sub x divided by d, and y would be d sub y divided by d. D can't be 0. Otherwise, if d was 0, you'd be dividing by 0. And by that tells you that there is either a dependent system, by the way, if the determinant of coefficients is 0, it says it's either a dependent system or it has no solution. It's one of the two. This only works when you have unique solutions. Does not work for dependent systems, does not work for systems where you have an infinite number of solutions. You have no choice but to use row reduced, to use the elimination method for those two. So here we go. Here's my system. First thing that I do, I calculate out the 3 determinants. So I know that x is going to be d sub x over d, and then y is going to be d sub y over d. So the 3 determinants, d is 1, 1, 2, negative 1. That gives me now the denominator for my answer. So down is negative 1, up is positive 2, and then down minus up, minus 1, minus 2 is minus 3. So that says this guy is minus 3. D sub x takes the column representing the x's, replaces it by the constant column. Down is negative 5, up is positive 6, down minus up, negative 5, minus 6 is negative 11. So that says it's negative 11 over negative 3. D sub y takes the determinant of coefficients, takes the y column out and replaces it by the constants. Down is 3, up is 5, down minus up is negative 2. So x is 11 over 3, y is 2 over 3. Cramer's rule.
Shouldn't it be negative? Why is it negative 11, negative 3? Change that to be positive 11.
What's the negative divided by a negative?
Oh, okay.
Yeah, positive, yeah. That's why I rewrote it,
Okay.
because you had a negative divided by a negative.